So I'm going to be showing you the program I made here that I tried to show in class, but I wasn't able to because Zoom classes were too short. But basically, this is a program where you input some points and then you try to get the plot of a polynomial that intersects the points you input. So for example, we can take a graph of a function, like say x squared. So you'll note that the point 1, 1 is a part of the graph, 1, 1, and then we have points like 0, 0, and we have 2, 4. All these points are like points on this plot. So what my program does is you give it some number of points, and you give it these points, and it will create this graph. It will tell you the polynomial that you made, right? But different points will give you different degree polynomial. So if you give it 2 points, it will give you a first degree polynomial that is just a linear equation, right? If you have 2 points, it just makes a line between those two. If you have 3 points, it will make a parabola, if you have 4 points, it will make a third degree equation, and so on. So you look at my program. If I type in 0, 0, 1, 1, and 2, 4, those were the 3 points as part of the basic parabola, like x squared. So this is that parabola. We see 0, 0, 1, 1, and 2, 4. This is kind of zoomed in, so I'm gonna do it again, but putting in more points so that it will get more zoomed out. So if you have 3 and then minus 3 square is 9, you have minus 2 square is 4, you have minus 1 square is 1, 0, 0, 1, 1, 2, 4, and 3, 9. I could do more, but if I draw this, see, it's a perfect parabola. And this is the equation of the parabola. So it looks a little weird, but that's just because I have my display isn't super well written. But it's 0 times x squared plus 0 times x raised to 5 plus it's 0 times x raised to 6 plus 0 times x raised to 5 plus 0 times x raised to 4. All this, the only term here is 1 times x squared. So if you simplify this is just x squared, which is exactly the graph I wanted. But it doesn't just work for parabolas. You can work with any degree polynomial. So if I say give it just 2 points, say 1, 2 and 5, 6, this will give me a linear equation. See, so this is the equation of the linear equation between those 2 points. But again, I can just type in any number of points I want. I can type in 1, 5, 6, and then minus 3, 2, 4, minus 3, 28, 1, all these things. And then if I intersect it, it'll give me this. Of course, all the few points I wrote at the beginning are all bunched up, and this is just all the way off. But this is a 4th degree polynomial because I gave it 5 points. And so yeah. So basically, I guess I'll explain how I made this. Because what I did was, earlier I made this library on my own of matrix multiplication and different functions. So I defined a bunch of functions like adding 2 matrices, or finding the determinant of a matrix, finding multiplying 2 matrices together, finding a transpose of a matrix, and also one called solve. But basically you give it a coefficient matrix, like we learned in class. Like if you have a system of linear equations, you can convert it into a matrix A into an unknown matrix X full of variables, and you can set that equal to a column matrix B, and then you can solve for X using like the inverse of A, and you can just find it. So then I have a code that does that. And then what that does is, in this program, is that it converts all the points into a system of linear equations where all the variables are the coefficients. So if we have a system of equations in 3 variables, right, so that's a parabola. That'll be ax squared plus bx plus c. So then and then we have that equal to set equal to y. So if we have 3 of these equations, right? So we have x1, say here we have x1, here x2, x3, and y1, y2, and y3, and then x, say 1, 2, 3, and also I need to put it here, 1, 2, 3. So in such an equation, there are x1 and y1, x2, y2, x3, y3 are all the points, right? x1 comma y1, x2 comma y3, 2, x3 comma y3. And a, b, and c are the unknowns. They're the variables. Those are the coefficients. So depending on what points you give it, it will give you different values. So if I want to make it instead of fourth degree equate, like give it 4 points, I need to make it ax cubed plus bx squared plus cx plus d. So then I would need 4 equations. So if I want to solve it for a parabola, that's 3 variables, that would be a 3 by 3 matrix I need to solve. If it's 4 points, I need a 4 by 4 matrix, and so on. It's a little confusing, I know. I don't fully know how to explain it, but the basic end result is just you give it some points and it just draws you a graph that of the line that intersects all of those. So yeah.